Experiment 4 is on chromatography, and chromatography is a very powerful method to separate components of a mixture. Sometimes the point of doing chromatography is to separate the components of the mixture, but sometimes it's to identify a particular mixture. And you've probably seen something like this before, maybe in a crime show or something where there's some little graph, maybe on a computer or maybe on a printout, where they say this is the signature of the gasoline that was used at the fire, and then they compare that to the same kind of signature from like a source of gasoline in some person's garage or something like that. And what's happening with this is that each of these little peaks, when you see this, is a different compound. So gasoline is a mixture, and by separating them out, you can see the relative heights of these, tells you how much of each compound, and the pattern of them to identify. So that's a kind of chromatography you may have seen before. We're going to do chromatography of dyes, because when you have like even black ink in a pen or brown ink or whatever, it may have more than one compound in it, each with a different color that contributes. So anyway, chromatography is a method to separate a mixture, and what it depends on are the differing solubilities. And when I say that, think about attractions. Molecules are attracted to other molecules, and so different molecules have different attractions, both to, in our case, it'll be to the paper and the solution. So there's always a stationary phase and a mobile phase. First, the mobile phase is, of course, moving, and it's moving through the stationary phase. The stationary phase is always porous, and our mobile phase is our eluting solution. And of course, it's a liquid, and our porous phase is our paper. And it's going to sit still as the solution soaks through and moves through the paper by capillary action. So elution is this process where the solution is moving through the paper as the paper soaks it up, basically. And we'll look at that in a minute. The RF, this is the retention factor. It is a measure of how far the spot, and the spot is the compound or component of a mixture, how far it travels versus how far the liquid, the mobile phase, is traveling. And we'll look at a calculation like that. Two things I want you to know about the retention factor besides the math is that the retention factor is unitless. In other words, we're going to be making measurements like in centimeters, but the retention factor, because it'll have centimeters over centimeters, it comes out, it's just a number. And the other thing is that it's always less than 0. In other words, it will always be like 0 point something something. Ours will have 2 sig figs probably. So, and that's because the number on top has to be smaller than the number on bottom. And we'll look at a chromatogram and see why that's true. When we process our chromatograms, the first thing we do is we're putting dyes on each of the X's and numbering them so we know which dye we put on which. And then we let these dry. And this is not the order and the colors that we're using, but just for example. And then we dip this dry paper, so this is our chromatography paper. We dip it down into our eluting solution. which of course is a liquid, and we don't let that liquid touch these spots, because if it did, it would just wash them down into the liquid. But what starts to happen is that, of course, you have paper and a liquid. The liquid starts soaking up, moving up this paper. And eventually, it just keeps moving up. Eventually, it'll end up way up here. And after the liquid has traveled up that far, the substances that were in this spot originally down here have moved up as well. And what happens is that, so this one has 3 compounds. In other words, 3 pigments. And one's green, one compound's green, one's blue, one's red, which is common for a black dye. Like if you have a black ink pen, it probably has several different compounds that make up that black color. Anyway, and then we could also say that this red compound is more attracted to the solvent than it is to the paper. That's a way to think about why it traveled up, because if these solvent molecules are really attracted to these molecules that are in the pigment will just move right up with them, and they'll kind of jump in the stream and move up to the top. The green compound apparently was really stuck to the paper more, so it may have traveled some with the liquid, but not as much. So up higher means it's more attracted to the solvent, down lower means it's more attracted to the paper. And so then what we're going to do is quantify like where these ended up. We're going to put numbers to the fact that the red ended up way at the top. Okay, this is redrawn, but so let's just look at it. We already said that how many pigments? In this case, we have 3 because there are 3 spots. So that means 3 different compounds went to make the black ink. And then we're going to practice doing the RF, retention factor. So to do the RF, what we need to do is do some measuring. And so when you have your ruler, you need to make sure that this line is where 0 is. So you'll line up your ruler to that line, not the bottom. Okay, so here, and then I'm just going to make some marks approximately, and this is in centimeters. Okay, and that's the biggest key, is to make sure you're measuring from this line, because that's where everything started. That's where the spot started. Okay, and then to get the RF, remember we're doing the distance from that the component moved, which is the spot, divided the distance that the solvent moved, which is the eluting solution. So let's go back here. And you're going to choose, I'm going to do the blue one, so I'm going to decide the middle of that. I could draw an X, but a line. Choose the middle of that, and then you're going to measure this distance here. And then over the same spot, you should measure the distance of the solvent. Notice that the solvent's front is not always straight. It's usually kind of dipped. And so you're going to have to get that distance over each of those, because it'll be different. Okay, so let's take measurements for this. And I'm going to go, since my thing is my ruler here only has a line for every centimeter, I'm just going to go one past. Actually, one past the decimal for your sig figs makes sense, because these spots are so big, we're estimating the middle of them. So I just go one past the decimal. So let's see. Let's number this. So it looks like the blue is pretty much on that 4. So I'm going to put 4.0 centimeters for how far the blue moved or went up. And then for the solvent, I'm looking up here, and I'm going to estimate that as 6.5. When we do this, our centimeters cancel, and I get 0.61538. That's what my calculator says, but I want to go to just 2 sig figs. Okay, and that is my RF. Remember, it doesn't have units. It is less than 1. It'll always come out 0 point something. If it doesn't come out less than 1, then you have flipped these. So make sure that it does. Theoretically, a substance's retention factor will be the same as long as the mobile phase, stationary phase, temperature are all the same. So that means that if I go back and look, let's go back and look. So if I started with green down here, when it moved up, it went into blue and yellow. But what we're saying is, notice that the blue is aligned with what the blue did before. So it's around the same height. And of course it'll vary a little because the distance here. But the idea is that ratio of how far it moves up relative to the solvent is fairly constant. So what this means, for example, is if you have a small piece of paper, and let's just say you start with a spot down here, and let's say you let it elute all the way up here, and you have a red dye and it ends up right in the middle. If it ends up right in the middle, that means that the spot is going to travel half as far as the solvent. So the RF would be 0.5. Okay, because whatever distance that is, the spot is half as much. So it's 1/2, 1/2, and that's what it would be. Well, if I took a larger piece of paper and it took longer, so maybe this one took 20 minutes, but this one took an hour, and I let it run till the solvent was all the way up there, where do you think this red spot would end up? Once again, it'll end up right in the middle because you can think of it as the pigment travels half as fast as the solvent. So the retention factor, again, will be 0.5. And so that's why, it's because it's a ratio. It should come out the same or close to the same each time.